Alright, hello guys, my name is Lazaro and today we're going to be going over an easy LeetCode problem. This problem is called diameter of a binary tree. Given a binary tree, you need to compute the length of a diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. So this definition of a diameter in a binary tree is very important because this is exactly how we're going to be solving this question. So let's read that again. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. Example, given a binary tree with root 1, left child 2, right child 3, and then leaves 4 and 5, we want to return that the diameter of this tree is 3. Because the longest path, as you can see right here, the 4, 2, 1, and 3, or the 5, 2, 1, and 3, it has a length of 3 because it has 3 edges. As you see right here, these little slashes, or what connects these two nodes, is called an edge. The length of path between two nodes is represented by the number of edges between them. So this is exactly what he said. So now that we read the problem, let's get into the intuition and see how we can solve this. So right here I already wrote down the example problem. We know that the right answer is this. It could either be that or it could also be this. Any of those two works and it would be accepted because that is the longest path. But how do we know the longest path? How can we keep track of this path? Well, something to keep in mind is at every single node we need to compute their longest individual path. So at this 5, what's the longest path from this 5 and downward? Well, this 5 has nothing to the left or nothing to the right, so this 5 is usually give 0. How about the 4? Since the 4 has nothing to the left and the right either, it would also be 0. Now, its path, it is 0, but when we're looking at 2, we want to take its left and right and then add +1. Since the path of this 5 is 0, but since 5 itself is a node, we want to do 5 + 1, and it changes that 0, and now this becomes 1. So, although it has no paths, it itself is a node, and it could be used as a path by another node. An example would be this 2. This 2 is we doing the exact same thing the 4 and 5 did. It will look to its left and it will look to its right. And now, since it does have children, here is where we want to check which direction or which route is longer. If I were to go left, would that give me a longer path if I were to go right? In this case, they will both give us the exact same length of a path. But we do want the maximum, which is something we want to keep in mind. Now the maximum between 1 and 1 is just 1. But if you remember, since we're taking into account the 2 is a node itself, we want to do +1. So 1 + 1, the max of its left and right paths, +1 is going to equal to 2. So just to explain what I did right there, the max of this +1 is going to give us this 2. Now, here at this 2, we can already see that we have the right answer because the longest path is 4, 2, and 5, which has 2 edges. So far we're building the logic correctly. But let's carry on. Now, for once we're looking at 1, we have to take its left and right. But before we can do its right, let's actually compute 3. 3 is going to be the exact same thing as 4 and 5. There's nothing on the left, nothing on the right. So the max of left and right will just be 0. But then we have to add a 1 to it. So 3 will just become 1. Perfect. So now we're on 1 again. Now we can actually do 1. 1 is going to get the max of its left and right, which in this case is going to be 2. And then it's going to add a 1, just like we've been doing the whole time. So this is going to give us 3. And that's how we actually get the right answer. So let's run that one more time with another example. Let me scroll down here. All right, so let's work with this example. At 5 is going to take its left and right, which is going to return 0 for its left and 0 for its right. And then it's going to take the maximum of that left and right. Since they're both 0, the max is just 0. But it's going to add a 1. So this is going to give us 1 for here. Now, when we're looking at 4, its left is 0, and then its right is 1, and it's going to take that maximum. The maximum is going to be 1, and then 1 plus 1 is 2. Now we're doing the exact same thing we did with 4 and 3. Its left is 0, its right is 2. The maximum between 0 and 2 is 2, but then we have to add a 1, so that becomes 3. Something similar for, let's do that. So it's not all the same. So for 2, its left is going to be 3 and its right is going to be 0. The max between that is 3 plus 1, 4. Now let's work on 8 and 9. And if you notice here, I've been working from all the way in the bottom of the left and then all the way in the bottom of the right. And then working towards the root. This should already give you a hint that we're going to be using depth first search. So let's continue. 8 has a left and right of 0. Max of that is 0. Plus 1 is 1. 9, similar thing. Left and right is 0. Plus 1 is 1. 7, max of left and right is 1. Plus 1 is 2. 6, max between 0 and 2 is 2. Plus 1 is 3. Now 1, max between 4 and 3 is be 4. Then plus 1 is going to be 5. Now, although we did get 5, we don't want to return 5. What we want to return, this 5 right here, it is what we're going to pass if 1 was not the root node. Our actual answer is left plus right, which is going to be 7. Because we want the longest path on the left plus the longest path on the right. So 4 plus 3 equals 7. Let's see if this is right. Well, let's find the longest path. This is one edge. This is another. This is the third, the fourth, the fifth, the sixth, the seventh. So one answer could be all of this. And another answer could be all of this. Because they both contain 1, 2, 3, 4, 5, 6, and 7. 7 edges in the path. And now, this is why I want to do another example. Because it's more than just finding the maximum between left and right and then adding 1. This one did seem a little bit misleading because it did end up with 3, but what we're supposed to do is add the left and the right at the end. In this case, it was also 3. So knowing that, we can now get into the code. We know we have to use depth first search. We know that we have to, for every single node, we have to return the maximum between its left and right, and then add 1. And we know to keep track of the right answer, we have to find the maximum left plus right path. So let's work on that. So let's first create the variable for our answer. Our answer, we're going to initialize it to 0. Let's say that the longest, our diameter is initially 0. Now let's create a function called depth first search, and it's given a node. Now if this node exists, if it's not null, then we want to find, we want to continue going deeper. We want to do depth first search on its left and right children. So left is going to equal to depth first search, and I'm doing this recursively, as you can tell. Depth first search goes to be done using a stack. So, oh, I actually messed up. I need to do depth first search node dot left, and then the right is going to equal depth first search node dot right. So this recursive depth first search logic right here is going to take us all the way to the bottom of the tree, and we're going to do this math first. Now, we want to update our answer to equal left plus right. Now, you might be saying, well, what is left and right returning? What is the function, this function, which is the one we're currently in, what is it going to return? Well, it's going to return what we talked about. It's going to return the maximum between the left and right plus 1. Now, let's say we hit a null node, a node that does not exist, that doesn't have a value. Well, else, if the node is none or null, then we want to return 0. And this is how we handle for example, this 5 right here. Since 5 is an actual node, we're going to hit this if block, and then we're going to call its left and right. But its left and right is non-existent. So left is going to, well, oh no. Okay. So since its left and right of 5 is non-existent, its left is going to, once we call depth first search, this function with an empty node is going to hit this else, and it's just going to return 0. So left is going to be equal to 0, and so is right. And then we're going to be returning 0 plus 0, or the maximum between 0 and 0, which is just 0, plus 1, which is the right number that we want to return. Perfect. So now we know that logic works. And this is really all we need. Since we're updating our answer variable to keep track of the longest path by doing left plus right, and we also were returning the maximum, the longest path of a single node of the node we're currently on, then that's all we need. We're done with this function. Other than that, all we have to do is call the function with the root node and then return the answer. And this is all we need to solve the question. This is all the logic we need. So now let's actually write out the code. Okay. Let me just move things around. There we go. Now I might type a little bit slow. I got a new keyboard, so Bear with me. So let's create that answer variable and let's initialize it to 0. Then let's actually create our function for doing the depth first search. Now, if the node is not known, if it actually exists, then we want to do this logic right here. We want to go all the way to the left and see what its left is equal to. Okay, and then also go all the way to the right and see what its right is equal to. And then from there, we want to update. Oh, this is actually something I missed. Instead of just doing left plus right, our answer is going to equal to max between our current answer and left plus right. Because like the problem said right here, this path may or may not pass through the root. So we will know that at the end, at the root, we're not totally sure that left plus right will give us the longest path or will give us the diameter of the binary tree. So every single node we're looking at, we want to update our answer to be either answer or left plus right, whichever is greater. So let's do answer is equal to max between answer, and I need to do self here. Oh my god, okay. Okay, there we go. And I also need to do self right here. Perfect. So the max between our current answer and left plus right. Perfect. And then what we want to return is just the maximum between left and right, whichever one of those is greater. And then let's just add a 1. Else, if we're looking at something that is not a node, what we want to do is just return 0. And that's all we have to do for that function. Everything else, we just need to call the actual function, given it the root node, and then let's just return whatever self.answer is. So now let's test this. Let's see if we did it right, or if there's an error. And there is. I missed an H. Let's try that again. So it works here. Now let's submit it, see if it's right. And it is perfect. So I hope you guys enjoyed the video. If this interests you, then I highly recommend that you join our Discord channel. It's going to be linked in the description below. We send out problems every single day for advanced and beginners. And we also do these videos to talk through the solution of these problems. So if that interests you, I highly recommend joining that server. Other than that, I hope you guys enjoyed the video, and thank you guys for watching.